When it comes to producing hydrogen, two of the most common starting materials are natural gas and coal. Both are carbon-rich fossil fuels, and while they've powered industries and homes for over a century, they also play a major role in shaping the future of hydrogen energy. Understanding the unique chemical and physical traits of natural gas and coal is essential because these properties influence how efficiently we can turn them into hydrogen or hydrogen-based fuels. Let's start with natural gas. This fuel is mostly made up of methane, which is a molecule containing one carbon atom and four hydrogen atoms. That makes it an attractive source for hydrogen production. But it's not just about how much methane is in the gas. Engineers and scientists also look at how pure the natural gas is and whether it contains any unwanted elements like sulfur or carbon dioxide. The cleaner and purer the gas, the easier and more cost-effective it is to convert into hydrogen. In most industrial settings today, natural gas is processed using a method called steam methane reforming technology that has been around for decades and is responsible for nearly 50% of global hydrogen production as of 2024. Coal, on the other hand, is a more complex story. Unlike natural gas, coal comes in various grades, such as lignite, bituminous, and anthracite. These types vary significantly in their carbon content, energy density, moisture level, and how much ash they leave behind after combustion. For instance, lignite coal has a higher moisture content and produces more emissions, while anthracite is cleaner burning but harder to access and more expensive. When coal is used for hydrogen production, it's typically processed through a method called coal gasification, which involves reacting the coal at high temperatures with steam and oxygen to produce a gas mixture called syngas. This syngas is then separated into hydrogen and other byproducts. Coal-based hydrogen production is still widely used in countries like China, where coal remains abundant and affordable. But there's a catch. Both natural gas and coal-based hydrogen production are known as grey hydrogen, meaning they emit a significant amount of CO during the process. In fact, it's estimated that for every ton of hydrogen produced using these conventional methods, between 9 and 12 tons of CO are released into the atmosphere. That's a big problem if we're trying to build a cleaner energy future. That's why researchers and companies are now investing in technologies like carbon capture and storage CCS to reduce emissions and turn grey hydrogen into what is called blue hydrogen. So why does all of this matter? Because the properties of the feedstock, whether it is the purity of natural gas or the grade of coal, play a huge role in choosing the right technology, optimizing efficiency and minimizing environmental impact. The better we understand these materials, the smarter and cleaner our hydrogen production methods can become. As the world pushes toward net zero emissions, hydrogen is expected to grow from 95 million metric tons in 2023 to potentially 660 million metric tons by 2050, according to the International Energy Agency. But how we produce that hydrogen and what materials we use will define whether it's truly sustainable. In the end, whether we're working with methane-rich natural gas or dense, energy-packed coal, the journey to hydrogen is one of chemistry, engineering, and increasingly climate responsibility. If we can improve how we use these traditional resources while transitioning to cleaner alternatives like green hydrogen, we stand a real chance at reshaping our global energy systems for the better.